Okay, so hello everyone. I hope my voice is audible to everyone. Okay, so Noma and Atif, any doubt in the last topic?
No, sir.
No. Okay, just give me a minute. Noma, any doubt in the last topic? And okay, and the last class I have given some homework. So Noma and Atif, you have completed that?
Sir, I did not receive any homework in the website.
No, not on the portal. From the slide, I have given some questions. You have completed that, Atif?
So you have two questions, right?
Yes.
Yes, sir. I completed only one of them. I can complete the other one and send it today.
Oh, okay, Atif. Just give me a minute. Okay, so I guess I've given the question up to question number 12. Okay, 13 we need to complete it. So only 3 questions are remaining in this chapter. We will complete that, and today we will start the inverse trigonometric functions. Okay. Okay. So next is this function. The function is from R to R. You already know what is meant by R. Okay. Fx is equal to cos x. So you are aware about this function. First, we need to check this is 1, 1 or not. 1, 1. Okay. So we have this one. Fx is equal to cos. We need to check that this function is 1, 1 or not. So any idea, Atif and Noma, can you tell me that this function is 1, 1 or not? Atif and Noma, any idea? Yes or no? No. Okay, not very sure. Atif, please tell me what's the value of f0 for this? That means cos 0. What's the value of cos 0?
1.
1. Very good. What's the value of f2 pi? Sorry, that means cos 2 pi. No more. What's the value of cos 2 pi? Noma and Atif. This is also 1. Okay. So 0 and 2 pi have the same image. That's why this function is not 1, 1. So we can write 0 and 2 pi have the same value, have the same, or we can say have the same image. Hence fx is equal to cos x is not 1, 1. Is not 1, 1. This is clear, Atif and Noma?
Yes.
Okay, next is for onto. Noma, please reply me on the chat box if this is clear. Okay, so Atif, can you tell me what is, okay, Noma. So both of you, can you tell me what is the maximum value of cos x?
1.
That is 1. Okay, you know the graph. This is 0. This is pi by 2. This is pi. Okay. So graph will start from here. Here we have a 1. So graph will be like this. Okay. And here we have a -1. Okay. Now we need to prove that this is not onto. Onto means if we will check both the sets, just give me a minute. If we will check both the sets, here we have R. Okay. And here we also have the R. If we will check our function, so the function is from R to R. So we have 2R here. If you will check this one, we will check here, then you have all the real numbers. But if you will check the graph of cos x, then the value of the cos x lie between -1 and 1. So that means from -1 to 1, whatever the elements you have here have their pre-images in setting, except these number from -1 to 1, except these, there are -2, -3, and so on. They do not have their pre-images in setting. Okay, there is no angle for the cos which will give you -2. So we can write like this: fx is equal to cos x. Okay, a real number except -1 to 1 do not have their pre-images, in do not have their pre-images. Okay, hence sorry, do not have their pre-images. Hence fx is equal to cos x is not onto. Okay, so Atif and Noma, this is clear. Why this is not onto?
Sir, cos 2 pi is -1, right?
No, cos 2 pi is 1. Please check here. This is pi. Okay, so this will be 3 pi by 2. Then you will get 2 pi here. So 2 pi value will also be 1. Okay, Atif?
Okay.
Okay. Okay, so I hope this is clear to everyone. Please note down this, confirm me, then we will do 2 more questions and this chapter will be completed and we will start in. And okay, so as you have seen that in relation functions, most of the question I have completed in class only. Okay, but in inverse and differentiation, I will give you a lot of homework, so please do that. Okay, inverse and differentiation are simple chapters, so you can do the questions on your own. Okay, please confirm me once you note down this one, then we will start the next question. Atif and Noma, this is done. Shall we start next? Okay, Noma, very good. Atif, this is done.
No,
Okay.
done, sir.
Done. Okay, very good. Next question is this, and okay, only 3 questions are remaining. Please check here. Now we have this set. Set A is what? Real number except 2. What is set B? Real number except 1. Function is from A to B. Okay, that is from these two sets, A to B. F is a function from A to B is a mapping defined by fx is equal to x minus 1 by x minus 2. We need to show that this is bijective. Okay, same concept. First of all, we will check 1, 1. Here we have this function A. So what we will do, we will assume let x1 comma x2 belongs to A such that fx1 is equal to fx2. fx1 means x1 minus 1 by x1 minus 2 is equal to x2 minus 1 by x2 minus 2. Cross multiply. x1 minus 1 into x2 minus 2 is equal to x2 minus 1 into x1 minus 2. Now open this bracket. So this will give you x1, x2 minus 2x1 minus x2 plus 2. And this is equal to, open this bracket. So this will give you x1, x2 minus 2x2 minus x1 plus 2. This plus 2 will cancel out. This x1, x2 will cancel out. And this minus 2x2, shift this to left side. Okay. Shift any one of these terms to the left side. So this is minus 2x1. We are shifting this minus x1 here. This will become plus x1. Here we have a minus 2x2. Shift this, we will get a plus x2. So here we will get minus x1. Here we will get minus x2. Cancel the negative sign. So you will get x1 is equal to x2. Okay. Hence, affix, hence the given function is 1. Atif and Noma, please confirm me. This is clear?
Yes.
Okay, very good. Please note down this and confirm it. Atif and Noma, please confirm me once it is completed. This is done. Atif and Noma, shall we start next?
Yes.
Okay, Noma, this done. Okay, very good. Now next one. Next we need to, okay, then I will erase this. Next, second is onto. Second is onto function. Okay. What we do in onto, we assume a value let y belongs to second set. Y belongs to b. Okay, such that fx is equal to y. Now what is fx? X minus 1 by x minus 2 is equal to y. X minus 1 is equal to cross multiply xy minus 2y. Okay, now we need to find x in terms of y. So what we will do, shift this part to the left side. So x minus xy is equal to minus 2y plus 1. Take out x common. So 1 minus y is equal to minus 2y plus 1. And from here we will get x is equal to minus 2y plus 1 by 1 minus y. Okay. Now we can say this for all y belongs to set B. Okay, there exists x is equal to minus 2y plus 1 by y 1 minus y belongs to A such that I will tell you how can we say this, okay, such that fx is equal to x minus such that just give me, such that fx is equal to x minus 1 by x minus 2, okay, hence it is onto function. Okay. Now, what we are saying here, for all y belongs to B, what is a B here? B is real number except 1. So if you will see this function, then this exists for every value of y except for what value of y this function do not exist? Roma and Atif?
Can you repeat?
Yeah, I'm saying that this function do not exist for what value of y?
1.
1. Very good. In the denominator, you should not have a 1. What we are saying here, for all y belongs to B. What is a B here? B means real number except 1. So what we are saying that here we can put any value except 1. So if you will put here any value except 1, then you will always get a real number. Okay. So we are saying for all y belongs to B, that is for all value of y except all real value of y except 1, there exists a value x. And now what is x? X is real number minus 2. So that means this value will never be equal to 2. Okay, because it is given here, real number except 2. So this should now never be equal to 2. Okay, in the bracket, you can show this thing. Okay, minus 2y plus 1 will never be equal to 2. Okay, how can we say this? Let's equate these two. 1 minus y is equal to 2. What you will get, shift this to the next side. Minus 2y plus 1 is equal to 2 minus 2y. Okay, then what we can say here, minus 2y will cancel out and you get a 1 is equal to 2, which is false. 1 is not equal to 2. Why we are getting this false value in the end? Because this value can't be equal to 2. Okay, so in the bracket, just write like this. So this means this value will never be equal to 2. The same thing we have written over here, that x will belongs to A. What is A? Real number except 2. Why we are saying that this is real number except 2? Because this value will never be equal to 2. So here we are saying for all value of y belongs to B, that is real number except 1, there exists a value of x, which is what? Real number except 2, such that fx is equal to y is equal to this one. Hence it is onto function. Okay, so Atif and Noma, this is clear? Noma
Yes.
and Atif. Okay. Noma, this is clear? Okay, very good. So please note down this, confirm me, then we will start next one. Okay.
Yes.
Done. Okay. Noma, this is done. Noma, shall we start next? Okay, very good. Okay, so we have only 2 questions left. Please check here for the 14th. We need to prove that this is bijection. Okay, now what is a function? Function is from A to B. the set is A to B, and next set is B cross A. Sorry, f is a function from A cross B to B cross A. So in place of a single set, they have given Cartesian product. And this is the function. So what we will do, we will assume two values from this set. So we will say let A1 comma B1 and A2 comma B2 belongs to A cross B such that the same concept, such that f A1 comma B1 is equal to f A2 comma B2. Okay. Now, what is mean by this f A1 B1? So this means B1 comma A1 is equal to A2 B2 means B2 comma A2. Okay, so this means B1 is equal to B2 and A1 is equal to A2. So this implies if these two are equal, then we can say A1 comma B1 is equal to A2 comma B2. Hence the given function is 1, 1. Okay, we have done nothing. We have assumed two value from the first set. We have equated the function. We get these two value, and at last we have written a1 b1 is equal to a2 b2. Hence, the given function is 1, 1. This clear, Atif and Numa?
Yes.
Okay, then please note down this. Confirm me. Then we will start the next question. Okay, Atif. Noma, this done. Shall we start next? Okay, okay. Okay, Noma, very good. Now we will do the second part. Okay. Now, what is the second part? Second is onto function. So here what we will do, we will assume a value from the second set. What is the second? B cross A. So we will assume let B comma A, because this is B cross A. So let B comma A belongs to B cross A. Okay, so this implies if this ordered pair belongs to B comma A, then this means B belongs to B and small a belongs to A. Okay, this implies if B belongs to B and A belongs to A, then we can say this implies A comma B belongs to A cross B. Hence for all B comma A belongs to B cross A, B cross A, there exists A comma B belongs to A cross B such that f A comma B is equal to B comma A. Hence the given function is onto this f a comma b is equal to b comma a is a bijection. Okay, so please note down this and let me know if this is clear to you. Then we will start a last question. Okay, and let me know if you have any doubt in this. Atif and Noma, please confirm if this is done.
Sir, can you explain once more?
Yeah, sure. So Atif, in this case, what we have done, we have assumed a value b from the second side. Second side is what? B cross A. So if this is B cross A, then we will assume B comma A. So we have assumed an ordered pair B comma A belongs to B cross A. Now, if this ordered pair belongs to this one, then we can say that small b belongs to B, small a belongs to A. Okay. If this value belongs to B, A belongs to A, then A comma B will belongs to A cross B. So if you have any value here, B comma A, then there exists A comma B which belongs to A cross B. For example, if you have this set B cross A, I'm saying that 2 comma 1 belongs to this, then this means 1 comma 2 will always belong to A cross B. Okay, the same thing we have written here. And this function is given fab is equal to b comma a. So this means whenever you will put this value f1 comma 2, then you will get the output 2 comma 1. So for every 2 comma 1, there exists 1 comma 2. For every 3 comma 4, there exists 4 comma 3. Okay, this thing we have written here. Okay, Atif?
Yes, sir.
So please confirm me if this is done, Atif. Then we will start the last.
Yes, sir, I finished it.
Okay, very good. Now next one. Show that this defined by if n is odd, if n is even. Okay, is many one on two. So first of all, we need to check 1 1. This is 1 1 or not. Okay, if we will
Sir, many
write
one means not on one, right?
yes, not 1 1. Okay, I've mentioned the heading 1 1. At last, we will say that this is not 1 1. Okay, so to show that this is many one or not 1 1, what we will do, we will give an example which have we will give two values which have the same image. So for example, if we will write n is equal to 1, then what will be the answer? F1 is equal to what? Here, if n is odd, then use this one. So we will write 1 plus 1, 1 plus 1 by 2, which will give us 1. N is even, n is equal to 2. Then F2 is equal to what? We will take this value, 2 by 2, which is equal to 1. So that means 1 and 2 have the same image 1. So we can write 1 and 2 have the same image, have the same image, 1. Hence the given function, hence the given function is not 1 1. Is not 1 1. This clear? Atif and Noma?
Yes.
Okay. Noma, this clear? Okay. Noma, in this question, we need to prove that this is 1 1. Sorry, many 1. Okay, this is not 1 1. So how can we show that? What is a 1 1 function? when different elements have different images. So if we will give an example where the two elements have the same image, then we can say that this is 1 1. So here we have taken n is equal to 1. If you are putting n is equal to 1, then n is odd. As per the question, if n is odd, then use this formula. Okay, so we will use this formula. 1 plus 1 by 2 will give us 1. Next, the value we have chosen as 2. So as per this, if n is even, use this formula. So 2 by 2 is equal to 1. So that means 1 and 2 have the same image 1. Okay, so it is not 1. This clear, Nubha? Okay, no more. Okay, Atif, please note down this and confirm me. Then we will start the next question.
Yes, sir.
It's done. Okay, so Atif, I'm just doing this second part here. Okay, because when the Noma will join, she can note down this. Next is onto function. Onto function. Now, for onto, just onto is quite complicated. Please check here. We have two sets. N set is here. Second n set is here. So for onto, what we will do, we will take a value here. Okay. Now there's a natural number. We will divide this natural number into two parts, odd and even. So what we will do, we will assume a value, odd number from here, and we will check that for odd number we have an image here or not. Okay, Noma, please check this onto. I will again explain you the 1 1 function. Okay, so here what we are doing, Noma, we have two sets, this and this, natural number and natural number. For onto, what we will do, this second set we will divide into two parts, odd and even. So we will assume a odd value and we will check that its pre-image exists or not. Then we will assume a even number. We will check that its pre-image exists or not. If for both the odd and even, their pre-images exist, then we will say that this is onto function. Okay. This is clear, Atif and Noma, that for what we will do in this question. Okay. Okay, Noma, very good. So first of all, what we will do, let n be an, okay, I'm assuming this n from this side. Please don't get confused. Let n be an odd number. Okay. Then there exists an odd number, an odd number 2n minus 1 such that f2n minus 1. Okay, so this is odd, so we will use the first formula, this one. So as per the formula, write this number plus 1 divided by 2, so you will get a, this will cancel out, you will get a n. Okay, so if we have assumed from here a number n which is odd, then for this there exists a number which is 2n minus 1. Okay, for this odd number n, there exists a number 2n minus 1. What is 2n minus 1? We will check here. If we will put this 2n minus 1, we will get a n. So for odd number n, there exists another odd number 2n minus 1. Okay, so we can say this 2n minus 1 is a pre-image of n. Similarly, if we will assume let n be an even number, then there exists an even number 2n. Okay, an even number 2n such that f2n is equal to 2n by 2 is equal to 2. Okay, so if we will assume an even number n, so for this even number, there exists another number here which is 2n. Okay, so for odd number we have a 2n minus 1, for even number we have a 2n. Hence for all odd and even number there exist their preimage. There exists their preimage. Hence, it is onto. Hence, the given function is on. Okay, I don't have the space, so I've written over here. Okay, so what we have done from the second set, we have assumed two values, one odd and one even. And we have shown here that for the odd number, there exists a value 2n minus 1. For even number, there exists a value 2n. Okay, why we are saying this 2n? Because when you will put this 2n in the function, you will get n. When you will put this value 2n minus 1, you will get n. So for both the odd and even number, there exist their pre-images. That's why this is onto. Okay, Atif and Numa, this clear? Atif and Numa, this clear?
Yes, sir.
So, Noma, this clear? Okay. So Noma, please check here for the 1, 1. Okay. For 1, 1, what we have done, we have put a value n is equal to 1, we get a 1. We have put a value 2, we get a 1. So 1 and 2 have the same image. That's why we are saying that this is not 1, 1. Okay. So Noma, this is clear. Okay, very good. So please note down this, confirm me, then this chapter is complete. We will start the new chapter, that is inverse trigonometric function. Okay. Please let me know once it is done.
Done, sir.
Done. Nova, this is done. Okay, very good. Okay, so this complete. Please revise this, and then you have a subjective test of this chapter. Okay. Okay, then let me start new chapter. Okay, so we will start a new chapter, that is inverse trigonometric functions. Okay, what is inverse of a function? We will please check here first of all that what is an inverse trigonometric function. You already know that what is a 1, 1 function, you know what is an onto function. Okay, if a function is bijection, then their inverse will exist. Okay, if a function is bijective function, then its inverse will exist. So we will check in this way that suppose this is a function A, sorry, set A, this is another set B. If the function is bijective, then what does this mean? Suppose we have A1, A2, A3, we have a B1, B2, B3. Okay, A1 is associated with B1, A2 with B2, A3 with B3. So if we will check this is 1, 1, we will check that this is also onto. So that means this function is bijective function. So if your function is a bijective, suppose this is a function from A to B. If a function is bijective, then you can write its inverse. Always remember, inverse of a function exists only if it is bijective. Okay, so this is a bijective function, so we can write its inverse. Inverse will be denoted by this one, f inverse. Function f is from A to B, so inverse will become from B to A. So we can write here like this. This is A and this is B. Sorry, this is B and this is A. Okay, what is B? B is B1, B2, B3, and what is A? A1, A2, A3. So what is inverse? Then B1 will be associated with A1, B2 with A2, B3 with A3. So if I will check this function is from A to B. This is bijective. That's why its inverse will exist and inverse will be from B to A. Please tell me Noma and Atif. This is clear that in what case we can write the inverse of a function? Because this is a base of your complete chapter. So if you have any doubt in this, please let me know. Okay. So I hope this is clear to you that if a function is bijective, then its inverse will exist. And what will happen with the inverse? Everything will become reverse. F is a function from A to B. Now F inverse will be from B to A. Okay. Now we will check this definition that what is the inverse. Corresponding to every bijection F, there exists a bijection. Okay. Corresponding to every function F, there exists another bijective function B to A. The same thing which we have discussed here. F A to B is a function, then B to A is a function. Gy is equal to x and fx is equal to y. Just check here. Then the function, this one, g b to a is called the inverse of the function and is denoted by this one. So what the complete statement written over here, I have already explained you from these two arrow diagram. This is clear, Atif.
Yes.
Okay, very good. So Atif, please note down this, and if you wish, please note down this arrow diagram. Okay, then we will proceed to trigonometric functions. Here we have just done a general definition. Next, we will check what is the inverse of a trigonometric function. Noma, please note down this, confirm me. Then we will start the inverse trigonometric function. Okay, this is only of an inverse of a function. Please let me know once it is completed. Atif and Noma, this is done. Shall we start next?
Yes.
Okay, Noma, this done. Okay, okay. Okay, Noma, very good. Now, next one. First of all, please check here. Let x is equal to sine theta be a function. Okay. In 11th also, you normally face these type of expressions. Let x is equal to sine theta be a function, then its inverse is theta is equal to sine inverse x. Okay. Please check here. X is equal to sine theta. Then theta will be what? We can write like this. Sine theta is equal to x. So theta will be equal to sine inverse x. Okay, please don't get confused this sine inverse with this one, sine x inverse. These two are different things. Sine x inverse means 1 by sine x, and this sine inverse x is different. Okay, so x is equal to sine theta be a function, then its inverse will be sine will shift over here, so this will become sine inverse x. But please note down this is not sine x inverse. This is a different thing. Okay, so we have assumed, we have checked this point. Now, what is a sine inverse? Sine inverse is a function whose domain is this and range could be any of the interval this, and this. Okay, this I will explain to you later on. What is the principal branch we will discuss later on, but first of all, we will discuss the graph of trigonometric function, because from the graph, we will try to understand what is a sine inverse function. So first of all, we will draw the graph of sine x. Okay, so I hope everyone remember the graph of sine x of all trigonometric functions. You might have done this graph in class 11th. Okay, sinus x graph means here you have a 0, here you have pi by 2, then you have a pi, then you have 3 pi by 2, and then you have here 2 pi. Similarly, here you have a minus pi by 2, then you have a minus pi, minus 3 pi by 2, minus 2 pi, minus 2 pi. Okay, this is x and this is this. Here we will write a 1 and here we will write a minus 1. So you already know what is the graph of sine x. For 0 the value will be 0. For pi by 2 this is a maximum value 1, like this. For pi this is again 0. Okay, for 3 pi by 2 this is minus 1. For 2 pi it is 0. Similarly for here, for minus pi by 2 this is 0, sorry, minus 1, and this is 0. Then for this maximum value, okay, so this graph is clear, Atif and Noma.
Yes.
Noma, this is a new chapter. This is an inverse trigonometric function. Okay, but we need the concept of bijective function here. That's why we have discussed that. Okay, this is an inverse trigonometric function, second chapter of your NCERT. Okay, okay. Now, first of all, please tell me that this is a bijective function or not. For your convenience, I will write this in the arrow diagram form. So this is A, this is B. Okay, the value which are there on the x-axis, we always write on A. So here we have a 0, we have a pi by 2, we have pi, and so on. We have many values. Here we can write some values, for example, -1, 0, 1, and we have a lot of values, but we will write only these. So for the 0, we have this 1. Sorry. Sine 0. Anyone can tell me the value of sine 0? Sine 0 is? Noma and Atif. Very good. 0. 0 will be this one. 0. What's the value of sine pi? What's the value of sine pi?
Zero.
Again 0. Okay. Sine pi is also 0. So 0 and pi have the same image. So this function is bijective or not? Atif and Noma. This function is bijective or not?
It is not bijective.
It is not bijective. Noma, this function is bijective? No. So its inverse will exist or not? Because just in the previous slide, we have discussed that only bijective function have the inverse. So its inverse will exist or not? Please tell me. No. Atif? If this is not bijective, then its inverse will not exist. But now the question is, if you will check the heading of your chapter is inverse trigonometric function. Trigonometric functions are not bijective, then how can we find the inverse of these functions? Okay, this is the main question. What we will do, if we are taking the complete real number, okay, then the function is not bijective. But what will happen if we will just take a portion? We will not take the complete real number. We will just take a portion, this one. If we will take this value minus pi by 2 pi by 2, now this function is bijective. Yes, you can see here from minus pi by 2 pi by 2, all these angles have the different images. Please check here. Earlier we have taken the example of 0 and pi. Now the pi will not be included. Now this function will be bijective. Okay, so how we will find the inverse of a trigonometric function? We will just take a particular portion of the trigonometric function. And for that portion, the trigonometric function will be bijective. And only for that portion, we can find the inverse. Okay, so there must be some standard angle which we need to take. Otherwise, what will happen? If you will take a particular set of angle, Noma will take another particular set of angle. Okay, so there should be some standard, and that standard is called the principal branch. Okay, so in case of sinusoidal function, that that principal branch is minus pi by 2 to pi by 2. Okay, so here for the sine x, we will take just from minus pi by 2 to pi by 2. And this minus pi by 2 to pi by 2 is the principal branch. This is clear, Atif and Noma? Because there's a
Yes, sir.
base of your chapter. If you have a doubt, then please let me know. Okay, because next you need to remember all these domains and range. Noma, this is clear? Very good. So we are finding the domain and range of sin x. Okay, then we'll find the domain and range of inverse. So anyone can tell me domain and range of sin x of complete interval. I'm not asking about only this. What is the domain of sin x? Very good, Noma. This is correct. Atif, what's the domain of sine? You can put any value. This complete R. Okay, so domain of sine is R. This clear, Atif?
Yes.
Okay, now what is the range? When you will put the domain, the value you will get, that is the range. So anyone can tell me the range of sine x. Very good, Noma. This is correct. Atif, what's the range of sine x? Range will be from -1 to 1. If you will check here, Atif, then the minimum value is -1 and the maximum is 1. And we are taking all the values between -1 and 1. So that's why the range of sine x is -1 to 1. This clear, Atif?
Yes.
Okay, so this part is of 11th, domain and range. Now we will discuss about again the inverse trigonometric function. So to find the inverse trigonometric function, what we will do, we will just take a portion of your trigonometric function. What portion we will take? We will take some standard angle, and that standard angle is called the principal branch. For example, for the sine, that branch is minus pi by 2 to pi by 2. Now what we need to do, now we'll find the inverse, sine inverse. So what we will do here for this sine inverse, okay, what here earlier the angle was on x-axis, the value was on y-axis. If we are finding the inverse, then everything will become opposite. Now the angle we will take on this y-axis, so here we will take a 0, here we will take a pi by 2, here we will take a minus pi by 2. The value which are given on the y-axis we will take here. This is 0, this is 1, and this is -1. Noma and Atif, please confirm me. This is clear?
Yes.
No, very good. Okay, now we will just take a portion of this. So if you will plot all these values here, then you will get a graph like this. Okay. For pi by 2, you will have a 1. So graph will be like this one. Only till here. For minus pi by 2, the value will be -1. So the graph will be like this. This is the graph of sine inverse. Now the question is domain of sine inverse. Domain of sine inverse. So both of you, please tell me what is the domain of sine inverse. I don't know why everyone has missed today's class. It's a very, very important class. Domain of sine inverse. Who can tell me? If you have any doubt, then please try to guess your answer. Okay, I will tell you one more thing. You already know about the domain and range of sine. Very good, Noma. This is correct. Always remember from the graph how you will get the domain and range. This x-axis will give you the domain and the y-axis will give you the range. Okay. Similarly, in sine inverse also, x-axis will give you the domain and the y-axis will give you the range. So Noma, your answer is correct. Atif, can you tell me the answer? What is the domain of sine inverse?
-1, 1.
Very good. -1 to 1. Okay, so we will use a closed interval, -1 to 1. Next, we have a range of sine inverse. Noma and Atif, please tell. No, that's not correct. Noma, range of sine inverse. Atif, what's the answer?
Real number.
No. Please again check this graph. Y-axis will give you the range. So if we will check, the values of this graph is from -π/2 π/2. We don't have this part in our graph. Very good, Noma. So the value is from -π/2 to π/2. And this will be closed interval or open interval? Closed interval, because we need -π/2 and π/2. So the range of sine inverse is -π/2 π/2, and this is called the principal value branch. Principal value branch. This is clear, Atif and Noma?
Yes, sir.
Okay, so now you understood that what is principal value branch. So you need to remember this now. Okay, throughout this chapter, we need this information that what is the domain of sine inverse and what is the principal branch of sine inverse. So you need to remember this. Okay, so first of all, please carefully draw this graph, write these values. And in the end, once we completed the graph, then I will give you the hint how to memorize this. Okay, so please note down this, confirm me, then we will do next one. Noma, in case if they will ask, then you need to draw the graph. But normally they do not ask to draw the graph. Okay. Okay, Noma and Atif, please confirm me if it is done. Then we will start the next graph. Very good question, Noma. Why the range of sine inverse is not real number? Noma, always remember that the range will lie on this one, y-axis. If you will check the y-axis, then this your graph is from -π/2 to π/2. In this graph, you have a value only from -π/2 to π/2, not the rest. Okay. Here we have written the domain of complete sine function, but we know that the complete sine is not a bijective. If we need a bijective function, we will just take a portion of this. So we have just taken a portion -π/2 π/2, and for that portion only we have find the inverse. So here we are talking about the inverse. If you will take the complete real number, okay, then its inverse do not exist. We have just taken a portion -π/2 to π/2. This clear, Noma? Okay. So Atif and Noma, please confirm me if it is done. Then we will start next. Okay. Atif, this done?
No, sir.
Okay. Have a good.
Yes, sir.
Okay, Atif, very good. Now next one. Second is cos x. Okay, first of all, we will draw the graph of cos x, then we will draw its inverse. So again, we have a 0 here. Okay, then pi by 2, then pi, 3 pi by 2. This is minus pi by 2. This minus pi. Okay, now for this next again, we have a here 1. This is minus 1. Now for cos 0, you know that this the value is 1. And then you have a value pi by 2. And for pi, you have a minus 1. 3 pi by 2, you have again a 0. Here you have a 0. For minus pi, you have this. And you have this one. Minus 3 pi by 2. So this is the graph. Again, this is not bijective. So we will again take a portion. So, but before that, please tell me the domain. Anyone can tell me what's the domain of this? What's it? Very good, Noma. Okay, Atif, this is correct. Real number.
Yes.
Now, Atif, can you tell me the range of this function? Noma, please reply on the chat box. What's the range of this?
-1 to.
Very good. -1 to 1. Very good. Now, we will draw its inverse, but again, we need a certain portion. Okay, that is standard. What is the standard here? Standard is 0 to pi. 0 to pi is the standard. Okay, so what we will do, we will erase the remaining part. We just need 0 and pi. Okay, we just need this portion, 0 to pi. We will draw its inverse. So second is cos inverse. So what will happen? Everything will become reverse. Whatever the values you have on x-axis we have the angle. So the angle will go over here. So we need what? 0. We need pi by 2. And we need pi. The value which you have on the y-axis, that will come over here. So this is -1 and this is 1. Okay. Now please check here this graph. First of all, for the 0, you have the value 1. So our starting point will be this 1. Then for pi, you have -1. Then you will have a value here. For pi by 2, you have a 0. So graph will cross from here. So the graph will be like this one. Okay. So in exam, if they will ask you, normally they do not ask for the graph, but in case they will ask you, then you can take the hint from the original graph. Now we will discuss about the domain. So who can tell me the domain of this function? Who can tell me what is the domain of this?
-1 to 1.
Very good, Mama. Your answer is also correct. -1 to 1. What's the range?
0 to.
Very good. 0 to pi. And this is called the, no, not minus pi to pi, 0 to pi. And this is also called the principal value branch. Okay. One more thing, as Noma has given the answer as minus pi. Noma, for minus pi to pi, this function will not be a bijective one. Please check here. From minus pi to pi, you will get many angles for which you will get the same value. So this is not bijective. But other thing is, can we take some other portion of the graph? Is it possible? For example, here we have taken the portion from 0 to pi. But is this possible that we can take some other portion? Yes, it will be possible. For example, 3 pi by 2, then we have a 2 pi. For example, we can take next portion this also, from this pi to 2 pi. But that is not a principal value branch. That is not a standard. So if an exam, they will ask you, is this possible to take some other angles? Yes, it is possible, but that angle is not principal value branch. So whenever in exam, in the question, they ask you to find the value of inverse trigonometric function, you need to find the angle which lie in the principal value branch. But yes, other angles are also possible to find, but we will always find the principal value. Okay, so please note down this and confirm me, then we will do another trigonometric function. Please confirm me, okay, once it is done, so that we can start the next graph. Atif and Noma, this is done. Shall we start next? Okay, Noma, very good. Atif, this is done.
Yes, sir.
Okay, very good. Now next one. Next is third is tan function. Tan x. Okay. So it's a graph of tan. Just draw like this. Okay. Tan is sine by cos. Cos is 0 for pi by 2. So that means we would write like this 0. For pi by 2, this do not exist. Next, we have a pi. Then we have 3 pi by 2. And we have 2 pi. So again, for 3 pi by 2, this do not exist. Here we have a minus pi by 2. So again, this do not exist. Next, we have a minus pi. Then we have a minus 3 pi by 2. Again, for this one, this do not exist. Now, what is tan 0? Anyone? What is this tan 0?
0.
Very good, 0. So we have this portion. For 0, this would be 0. For pi by 2, this become like this. Infinite. For 0, this is 0. For minus pi by 2, this would be like this. Similarly, for here, this graph will be like this. Similarly, from here, this graph will be like this graph will be like this one. Okay. Now, anyone can tell me the domain of this? Please, no, not every real number. For pi by 2, this do not exist. Okay. You can think like this, tan is sine by cos. So cos will be 0 for what angle? Pi by 2. For pi by 2, this do not exist. So we will write domain is R except multiple of pi by 2. So 2n plus 1 pi by 2. This clear? No more? Okay, very good. Now anyone can tell me the range of this? Anyone can tell me the range? Not 0 to infinite number, minus infinite to plus infinite. Or we can say complete R. Please check here this graph. This graph is from minus infinite to plus infinite. This clear, Atif?
Sir, can you explain the domain?
Domain, yes. Atif, please check this. What is tan? Tan is sine by cos. Cos is 0 for what angle?
Pi.
Pi by 2. Multiple of pi by 2. Or we can say odd multiple of pi by 2. Okay, so this denominator is 0 for pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, and so on. Okay, so that means in case of 10, we do not need this pi by 2 because for this do not exist. Tan do not exist for pi by 2, 3 pi by 2. So this is the odd multiple. So how can we write the odd multiple like this? 2n plus 1 pi by 2. Okay, in place of n, if you will put any value, you will get all these angles. So what we need, we don't need this one. So what we will do from the R, we will subtract this. Clear, Atif? Domain?
Yes, sir.
Okay, very good. So I hope range is also clear. Now, we will find the inverse. Again, we need a principal value branch. So you can't remember the principal branch of all the trigonometric ratios. Okay, so you need some relation. So please remember the domain and range of sine inverse and cos inverse. And from these two, we will take the hint. For tan, tan is similar to sine. So uh, what is the domain name? Not sorry. What is the range of this sine inverse? Who can tell? What is the range of sine inverse? Noma and Atif. What is the range of sine inverse? We have already done this. Very good, Noma. Okay, please check here. Minus pi by 2 to pi by 2. This clear, Atif?
Yes.
Okay, so 10 will be similar to sine inverse. Okay, so we will take this value, but does tan exist for pi by 2 and minus pi by 2? Tan exists for pi by 2 and minus pi by 2. True or false?
False.
False. So what we will do, we need this one, but we don't need minus pi by 2 and pi by 2. That's why we will take an open interval. Okay, we will take an open interval. So open interval means minus pi by 2 and pi by 2 will not be included. Okay, so the principal value branch for this tan inverse will be, we can write directly here that range we will take, range will be equal to minus pi by 2 to pi by 2. So we get a hint from here. From this, we can draw the graph. So again, reverse the values. Angle you have on the x-axis, we will shift this angle on the y-axis. So on the y-axis, what angle we need? We just need minus pi by 2. Okay, we just need pi by 2 and 0. Okay, now we will check this. This is 0. Okay, so we need also 0 here. Now, for we don't need this. We don't need minus pi by 2. That's why we have drawn a dotted. Now your graph will be like what? From pi by, it will not touch this pi by 2. So the graph will be like this. So just take a portion, take this portion from minus pi by 2, pi by 2 from the graph and plot it like this. You will get the graph of inverse. Okay. So range we have already decided. Anyone can tell me the domain of this? Very good, Noma. This is correct. Atif, what's the domain of this one? Atif, what's the domain of this?
R.
Very good. This is complete R. Atif and Noma, please let me know if you have any doubt in this one. Okay, we need these values. We need these values. You need to remember this, but I will give you the hint how to remember this one. So please note down this, confirm me, then we will start the next graph. This is done. Atif and Noma, shall we start next? Okay.
No, sir. 1 minute.
Okay.
Done.
Okay, Atif. Very good. Next one. Noma, this done. Shall we start next? Okay, very good. Now the fourth is cortex. Okay, so the graph of cot is what? Caused by sine. Sine do not exist for 0. Okay, so we get a hint from here. So this is 0. So for 0, we will draw a dotted line. A dotted line we will write for those angles for which your function do not exist. Similarly for pi. Okay, for pi also we will draw dotted. Similarly for 2 pi we will write dotted. 2 pi. This is pi by 2 and this is 3 pi by 2. Here you have a minus pi by 2. Okay, again for pi you will draw a dotted line. Again for 2 pi you will draw the dotted line. Here you have what? Sorry, this is minus 2 pi. This is minus 3 pi by 2 and this is minus pi. Okay, so what's the value of cot pi by 2? Cot pi by 2 is 0. Okay, so the graph will be like this. For 0 it will go to infinite, and for this 0 graph is great. Similarly here. Okay, similarly here this will be its direction. Similarly here. Okay, so this is the graph. Domain, anyone can tell me what's the domain of this? What's the domain of this one? This, please check the denominator sine. Sine do not, this sine is 0 for what? 0. So r except n pi. Okay, n can be an integer. Anyone can tell me the range of this? What is the range of this one? R. Very good. Now we will draw the inverse of this, but again we need the principal value branch. So what is the principal value branch for cos? What is the principal value branch for cos? Please turn your pages.
0 to
0 to pi. Okay. Now this cot do not exist for 0 to pi, so we will take a open interval. Okay, so what we will do, we will draw the cot inverse and we will, the angle we will take on this y-axis. So 0 to pi means here we will write 0, here we will write pi. So in the center we have a pi by 2. This do not exist for which value? 0 and pi. So we will draw the dotted. Okay. Now, for this one, for 0, the value is infinite, and this will come up to pi by 2, and this will be drawn like this one. So this will be the graph of cot inverse. Now, please tell me the domain of this. Who can tell me the domain? Domain is
R.
what? Very good. Domain is R. What's the range? Range is
0 to pi, open interval.
very open interval. Very good. Okay. Please note down this. Then only 2 graphs are left. We will do that, and then we will start some questions. So everyone, this is done. Shall we start next? Atif and Noma, this is done. Shall we start next?
Yes.
Okay. Okay, Noma. Okay, Noma, very good. Next one. Next is fifth. Fifth is cosecants. Okay. So cosec is what? 1 by sine. Sine is 0 for 0. So that means for 0, we will draw a dotted line. So this is 0. Then we have a pi. So for pi, we will draw dotted. Then we have this 3 pi by 2. And we have 2 pi. So on 2 pi, we will draw dotted. Then here we have minus pi. So at this one, we will draw dotted. Then we will draw dotted for minus 2 pi. Now this is pi by 2 minus pi by 2 minus 3 pi by 2. Now, Atif, what's the value of cosec pi by 2? 1. Okay. So the value will be 1. After this, it will go in this direction. Similarly, here it will go in this direction. For 3 pi by 2, the value is minus 1. It will go in this direction. Again, here the direction will be this. And here the direction will be this one. So this is a graph of cosines. So please tell me what is the domain of this. What's the domain of this one? This do not exist for what value? This one's for 0, pi, 2 pi do not exist. So r minus n pi. Range. Anyone can tell me the range of this? Range is, what is the range of this function? R, except, please check here. In the graph, this portion is not there. So R except minus 1 to 1. -1 and 1 is there, but the middle portion is not there. This clear? Atif?
Yes, sir.
Noma, this clear? Okay, Noma, you understood. Very good. Now again, we need the principal branch for cosec inverse. Okay, so cosec is also related with sine inverse. So what is the principal branch for sine inverse? What is the principal branch for sine inverse? Minus pi by 2, pi by 2. Very good number. Minus pi by 2 to pi by 2. So cosec inverse is also related with this. Now please tell me from minus 90 to 90, for which angle this cosec inverse do not exist? From minus 90 to 90, for what angle this cosec inverse do not exist? No answer?
9.
0. Because for 0, the sign will become 0 and in the denominator we have a sign. So except 0. This clear? No man Atif?
Yes, sir.
Okay. Now, so this is a principal branch. This is principal value branch. Noma, what is the value of sine 0? Noma, what is the value of sine 0? 0. Cosec is what? 1 by sine. Okay, so if sine will become 0 for 0, we can't take the 0 here. In the denominator, you never have a 0. That's why we need to ignore the 0. Clear, Noma? Okay. Now, again, this minus pi by 2, we will take here minus pi by 2. We will take here pi by 2. Here we have a 0. Okay. Then we have a value 1 here. Then we have a value minus 1 here. We'll draw it here dotted because we need to start the graph here. And we will draw here dotted because we need the graph here. So for pi by 2, the value will be 1. And after this value will increase like this. For minus pi by 2, the value is minus 1. And after this, the value will increase like this. So this is the graph of inverse. Okay. So please note down this and confirm me if you don't have any doubt in this. Then we will do the last graph, that is sec inverse, and we will start some questions.
What about
Okay, very, very good. So can you tell me domain, Atif? Atif and
minus 1 1?
same, very good. Rx minus 1 2. Okay. So please note down this, confirm me, then we will do the last one. This is done. Atif and Noma.
No.
Okay, Roma, this done. Okay, very good. So we will do the last graph. Sixth is sec x. Okay. Now, this sec is what 1 by cos. So cos do not exist for pi by 2. So 0 is okay. For pi by 2, we will draw the dotted line. Then pi is okay. Then this 3 pi by 2, we will draw dotted line. Again, for minus pi by 2, we will draw the dotted line. Then we have minus pi. Then we have a minus 3 pi by. Okay. Now, here. Okay, for the 0, you have the value 1. Okay, so pi by 2, we do not have any value. Here also, we do not have. Pi value is minus 1. This is minus 1. Like this. Okay, so domain is what? Anyone can tell me what's the domain here? R, except we don't need this pi by 2, 3 pi by 2. So 2n plus 1, pi by 2. What's the range here? Range is? Anyone? What's the range?
R
Very good.
minus 1 1 open
R,
ring.
yes, I know you are getting bored with this graph, but this is the last one. This is the range. Now we need the again the standard value. This sec is related with cos. So what's the principal branch for cos inverse? What is the
0
principal
pi.
branch? 0 to pi. But is there angle for which the sec do not exist in 0 to pi?
Pi by
Very good. So we will subtract pi by 2. Okay. So here, what is the range? Range is 0 to pi, except pi by 2. Okay. Now we'll draw the graph of this. So we just need 0 and pi. So here we have a 0 here. Then we have a pi here. Then we have a pi by 2 here. Here, draw the dotted line. Okay, so, and here we will take a value 1. Here we will take a value minus 1. For 0, the value is 1. So the graph will be like this. For minus 1, we have this pi. The graph will be like. Okay, so this is the graph, please. Okay, and what's the domain of this? Domain is what? Yes, R, except minus 1 to 1. So please note down this quickly. Then we will check that how we need to remember these values. Okay. Noma and Atif, please let me know once it is done. Okay, Noma. Atif, this done.
Yes.
Okay, very good. Okay, so our graph is done. Now we will form this table, domain and range of trigonometric, not trigonometric, inverse trigonometric. Okay, please write here, inverse trigonometric. First one. First is sine inverse. Okay. So first is sine inverse. So first we need the domain. Second, we need the range. Now for the domain. Okay, domain you need to remember. Okay, so that's the easy part. Range, I will tell you the trick to learn it. Not cos inverse. Okay. Then tan inverse. Then for this cosec inverse. Then fifth we have a cot inverse. Six is seconds. Okay. So domain you need to remember. So anyone can tell me the domain of the sine inverse? Just R. Okay. Try to recall from the graph R. Cos inverse domain. Cos inverse domain. Try to recall from
R.
the graph. Again R. What's the tan inverse domain? No. I'm sorry. What we have done. Sorry. Yes. Sine inverse is -1 to 1. Similarly, cos inverse is -1 to 1. What's the tan inverse domain? R. What's the cot inverse domain? R. What's the cosec inverse domain? R except -1 to 1. Sec is R except -1 to 1. This you need to remember. Okay, and this is not a tough topic. Okay, you can remember this domain. So the difficulty you will face is in range only. Sine and cos inverse range you need to remember. So anyone can tell me what is the range for sine inverse? Principal value branch.
Minus pi by 2 pi by 2.
Minus pi by 2 to pi by 2 closed interval. What's the for cos inverse? What's the range? Cos inverse, very good. Nomad is correct. Atif, what is the range for cos inverse? 0 to pi? Clear, Atif?
Yes.
Okay. Now tan inverse. Please remember that this tan inverse is related with sine inverse and where is it? Cosec inverse. Tan inverse, cosec, and sine are related. Cos inverse, I will write hash. Cos inverse, cot inverse, and sec inverse, these are related. Okay, in your final exam, when you have a complete syllabus, then it is not possible for you to learn all these values line by line. So please try to remember these values in this way. In final exam, you will forgot these values. Okay, so write this, that sine inverse is related with tan inverse and cosec inverse. Now, what is the range for sine inverse? Minus pi by 2, pi by 2. For tan, we will again write the same thing. Now, please try to recall that for what value tan inverse do not exist. Anyone? No, mine are. For what value the tan inverse do not exist? Try to learn in this way.
Pi by 2 and minus pi by.
Yes, tan is what? Sine by cos. So denominator is 0 for what? Pi by 2. So for this value, this do not exist. So write the open interval. Now check for cosec. Again, write minus pi by 2 to pi by 2. Is there any value in this angle for which this cosec inverse do not exist? Anyone? Is there any value in this angle for which cosec inverse do not exist?
Minus pi by 2 and pi by 2.
No, not minus pi by 2. Cosec is what? 1 by sine. Sine do not exist for what? 0. Okay. Clear? Atif and Oma? Today we will not
Yes.
be able to start a new next topic. Okay, no issue. Next one, cot inverse. Cot is related with cos inverse. Okay, so cos inverse is 0 to pi, so we will write 0 to pi. Now in this 0 to pi, for what value this cot do not exist? So remember in this way, chord is what? Cos by sine. Sine do not exist for what? 0 and pi. Sec is what? Again 0 to pi. Sec is what? 1 by cos. Cos do not exist for what? Pi by 2. So write minus pi by 2. This is clear? No, Maya Natif?
Yes.
No more? Okay. Okay, so please try to remember this complete table. Okay. We need all these domain and range in every question of inverse trigonometric function. So your homework is please revise all the graph which we have done today and learn this table